State observer is introduced in this video. State estimation is important in state space model and control. In state feedback control system, all state is need to be used in controller. Observer is presented in page 145 to 147 of the textbook. The topic of state observer is in week 03 in MATLAB grader. This slide shows notations about state space realization. T is the time and x is the state vector. X is a function of t, and u and y are control input and control output respectively. N is the order of the system and A is a matrix. State observer is a mathematical tool used in control theory to estimate the internal state of the dynamical system. A state observer consists of input and output and a known system model. Since not all state variables of a system can be directly measured, state observer play a critical role in control system. For deciding input value by u equal minus kx, it is required to know all value of x. State x of the plant should be always detected by using sensors. However, it is difficult to detect all state value because of the sensor location, cost, and so on. So it is required to estimate all state using detectable sensor output and input signal information. In case the system is observable or detectable, state of the plant can be estimated by using state observer. When the rank of observability matrix U is n, the plant is observable. The detail is presented in another video. Concept of state observer is shown in this slide. When input is added to plant and output is obtained, then if we consider copy of plant as a mathematical model, then when we input the input signal to the copy, then we obtain the output. It is expected that the state in the mathematical model is similar to the state in the plant. In addition, the error feedback is used in the copy of the plant. Then the observer form is given based on the mathematical model. This equation shows the form of the state observer. X tilde is estimated state and Y is the output. U is the input. L is the observer gain, and we can find that the model output and the plant output are considered in the observer. By considering the difference between state observer and the plant, we can obtain the dynamics of the estimated error. We can find that when we select appropriate L in this system, E goes to 0 by t goes infinity. This slide shows the case of discrete time system. We can find the similar manner we can obtain the state observer form is given. In the state feedback control, estimated state is used instead of the state value. This slide shows the observer-based control system. We can find u equal minus kx tilde is obtained. Entire system is given by these equations. State feedback and state observer are given. And estimated error is given like this. Then the observer-based control system is given by this form. We can find the design parameters are not only k but also l in this entire system. This is another form of observer-based control system, and the state of this system is x and e. We can find the pole of the system is given by two components. One is pole of A minus BK and another is pole of A minus LC. For achieving dynamics by A minus BK for the observer-based control system, it is required to assign the poles of A minus LC as far from imaginary axis like this.